Next Thursday, Friday.
It goes Thursday, Friday, and Saturday, so we'll be there on Friday and on Saturday.
All right, today we're modeling with functions. So we're going to look at functions with formulas, graphs, verbal descriptions, and data. Why? Because a function is used to model a variable under observation in terms of other variables. It often allows us to make predictions in practical situations, such as predicting the future growth of a business. Now, usually, but not today, we do a maximum value problem where, okay, I have a piece of paper, I'm going to fold it into the box. What's the maximum volume of the box? What should I cut off of each corner? Okay, so you have a piece of paper. You cut off these parts. This, and this. These are each X by X. Okay, the piece of cardboard was originally 15 in this side by 8 this way. Okay, you cut off these and then you fold up the sides. So if this is X by X, it's X tall. It's 8 minus 2X this way, 15 minus 2X this way. This is a volume function. So if you multiply that all out, and then in calculus, we would multiply that out and take the first derivative, which would be the shortcut. But if we multiply this all out and look at the function, and we'd use our graphing calculator to find the maximum occurs at 1.67 repeating. So the height of this should be 1.67. 2 times 1.67 is like 3.1 or 3.3 repeating. So the side of this would be 4.67, and this side would be 11.67, something like that. Okay, and that would be the maximum volume of the box. Because if you make this any bigger, these become smaller, and the volume thus decreases. Okay, so if we look at the graph, see how the volume keeps getting bigger until this point, and then starts getting smaller again. So you guys know how to find the maximum of a parabola on your graphing calculators already. So that's what that is about. Okay, so we can also look at data, see data trends, and figure out what's going on with the data trend. So the data is the dots, and what we can do is use our graphing calculator to find a line of best fit, and then use that line of best fit to make predictions about what happened in like 1999, or what's going to happen if we extend out this line in 2023. Okay, that's using lines of best fit. Okay, so functions. When you graph a function and you see that you need to make a line of best fit, if it's a straight line, for the most part, use a linear function. If it's curved like this, quadratic, you got a cubic and quartic, okay, to the 4th power. A natural logarithm looks like this. The ones that we use to predict most of the time are exponential. That's exponential growth. This is exponential decay. We could also have a power function, logistic, or sinusoidal. So that's just some of the graphs that you'll see, that you need to match up with graphs. But we're not doing so much of that today. So what are we doing today, Mr. Bierschbach? Well, we are solving problems, and we start out with very basic ones. Okay? We start out with like algebra 1 problems. 1 more than 4 times a number. A number, if we don't know the number, is x. So 1 more than 4 times a number. Okay, we'll start with the very basic, and then we'll build from there. 30% of a number q is 0.3 times q. The area of a rectangle whose length is 7 more than the width. Well, if we draw a rectangle, the area is what we want to find out. We know the length is 7 more than the width. If the width is x, what's the length? 7 plus x. So it's x times x plus 7. Okay? After a salary after a 2.1% increase when the salary is y dollars. Okay? Do you take y times 2.1? No. Y times 0.021, right? But that's not your salary. That's just the increase. So then what's your salary? You have to add that on to y. So you could say it's 1.021y. Okay? That's what your new salary is. The 1y plus the 0.021y. Okay? Sell price of an item marked at X dollars if 25% is discounted from the market price. Okay? The sale price of an item marked X dollars. The sale price of an item marked X dollars if 25. Okay. So the sale price is X. What was the original price? Well, the original price is so X would equal 0.25 times the original. Okay? So the sale price would be X divided by the original price. I'm not reading this right. Okay. Okay. The sale price is the original price minus 25%. So the sale price is 75% of the original price. Okay, there we go. The total cost is $13,500 plus 6.75 times each item produced. You have that in operating expenses, startup expenses, plus it costs that much to produce each item. Okay? All right. The revenue is just the cost, whatever you get for it times the number of items. So it's $3.48 per item. Employees' new salary is this after giving them 5% raise. What was the salary before the raise? So the salary before the raise times 1.05 should equal 20,370. Okay? Because that's what you had before, and then you multiply it by 5% plus the original salary, so 1.05. So to find the original salary, we just divide by 1.05. A traveler averages 52 miles an hour on this trip. How many hours? Well, you just divide by 52. Okay. Cell phone antennas grew from this to this. What is the increase over a 1 year period? You take the bigger number minus the smaller number. Whatever that is, you divide that answer by the original number to find the percent increase. Okay? College athletic field is 92 meters in perimeter. Okay? The length is 12 more than the width. So if the width is W, the length is W plus 12. So you add them up. So 4W plus 24 equals 92. Figure out the width, figure out the length. A mother wants to invest $10,000 in her son's education. Part earns 4%, part earns 7%. The total interest after 1 year is $600. How much was invested in each? Okay. So the interest, so you have X at 4%, 0.04, plus $10,000 minus X, because if you have $10,000 total, X of it is invested at 4%, the other is invested at 7%, and that should equal $600. You solve that equation to figure out how much was invested with a CD at 4%. What type of graph does this look like? Out of all my graphs I did, it's a parabola, it looks like, so it would be quadratic. Okay, so those are the types of problems that you'll have today. I simplified it from some of those building a box and finding maximums and all that. So there you go. I'll let you get started now. We get out of here at 1:10. So you have 20 minutes. So you can, some of you can bang this out right now. Monday we're reviewing for the chapter test. Doing the practice test. Yeah. I'll even